Hello, class. To help you review for the final exam, I would suggest that you try problems 5 through 10 on the exam number 3 sample problems and check your answers by going to math.unm.edu/KevinB. Click on 1440 classes and you'll see exam number 3 sample problems, and then you'll also see exam number 3 answer key. So try the sample problems, see if you can match that answer key. Okay, and now for the rest of the time, I just want to go over a few problems from Trig, chapter 12, because that will be on the final. Remember, only study those things that are going to be on the final. See my last either on Learn announcement or class email, I can't remember. I told you exactly what sections will be covered. All right, so here we go. Let's take a look at this old test 3 I have. So the first question is, find the derivative and simplify. So here's our first question, 7a. We're given a function x squared times the sine of 2x. How would you find the derivative? Think about it for a moment. Okay, so what I'm thinking is I see a product. It's really x squared times the sine of 2x. So to find the derivative, we're going to do the product rule. The way I do it is the first times the derivative of the second, which is sine 2x, plus the second times the derivative of the first. And then you want to be sure to simplify your answer. So here we go. The derivative, make sure you write f prime of x equals, and the first is the x squared, and then times, what's the derivative of sine 2x? Is the cosine of 2x, and then by the chain rule, times 2, because that's the derivative of the argument 2x. So there's the first times the derivative of the second, plus the second, well, my second factor is sine 2x, times, and what's the derivative of my first factor, x squared? It's going to be 2x. And then I just simplified for my final answer. So I put this 2 in front of the x squared. It looks nicer that way. So 2x squared cosine 2x plus 2x, I put the 2x in front, times the sine of 2x. And we're done with that question. Now let's go to a function where we see a quotient. I want to find the derivative of f of x. I see a quotient, so I'm thinking quotient rule. Remember, derivatives have product rules and quotient rules. So as a word of caution, make sure you use a lot of parentheses, because the quotient rule is low d high. It's all of low. So that 1 plus cosine x must be in parentheses, times the derivative of the numerator in parentheses. So make sure you know these rules or have them very handy. You don't want to waste a lot of time looking all through your notes. Try to be really organized with your notes before you take the final. So that way you can maximize your time. Have that trig unit circle sheet handy. Have all your chapters in order for your notes so you can find things quickly. You don't want to flip through all your notes and wasting time. Okay, so here we go. To find the derivative, I'm going to use the quotient rule. And look at those parentheses. It's the low or denominator. So the denominator is 1 plus cosine x. So it's 1 plus cosine x times the derivative of the numerator. So the derivative of the x is 1 minus, and then the derivative of sine x is just cosine x. And then, so there's my low d high, minus, the quotient rule always has a minus. And you got to make sure you do the right order. You got to start with the denominator times the derivative of the numerator, low d high, minus high, and the numerator high is x minus sine x. Notice that must be in parentheses, all of that, times the derivative of the denominator. The derivative of this 1 is 0. All constants have derivatives 0. And the derivative of cosine x is the minus sine x. And then that's going to be all over the denominator squared. Again, parentheses, all over the denominator squared. And then I FOILed this out, and saving time, I used the shortcut a plus b times a minus b is a squared minus b squared. But you'd get the same answer if you FOILed it out. And then minus a negative is a plus. So plus x sine x minus sine squared x. Try not to make sign errors there. There's a bunch of ways you can do that. all over the denominator squared. Keep your denominator in factored form. Do not FOIL this out. The denominator is best in factored form. Okay, and now let's see what we did next here. 1 minus cosine squared x is actually sine squared x. Because if sine squared x plus cosine squared x is 1, that means 1 minus cosine squared x is sine squared x. So that was a Pythagorean identity. So have those identities handy. Okay, and then I got the plus the x sine x minus the sine squared x. And then these cancel out because they're opposites. So my final answer, the derivative, right here, f prime of x is equal to, and there's the final answer, x sine x over 1 plus cosine x all squared. You can try these problems later and see if you can match these answers. You can pause your video. Okay, let's go to a couple more questions here. Now we're doing integrals. Find the integrals. So this first one isn't too bad. It's just the integral of a difference. So if you want to, this is optional, you can write it as the difference of the integrals. You don't have to do that step. Either way, here's the final answer. It's going to be the integral of the first term is the x cubed over 3 minus the integral of cosine 2x is sine 2x over 2, because it's an antiderivative. So don't go times 2 like you would for a derivative. You go divided by 2. The derivative of 2x, the argument is 2. So with integrals, you divide by that derivative of the argument. And then don't forget the plus c. Okay, one more question, and that will be it for today's video. And I'll post more videos. So this looks interesting. It's a definite integral, so we should get a number answer. Definite integrals have a number answer. These are definite integrals because we have numbers here. Whereas if you have an indefinite integral, you always get that plus c at the end. Okay, so this is actually going to require a u substitution. Remember, there is no quotient rule for integration. So if I let u equal the denominator, the derivative would be the numerator, actually, directly. So that seems like a good idea. So here we go. For my secret thoughts, I said let u equal the denominator, 1 plus sine x. And then du dx, the derivative of u with respect to x, is just cosine x. The derivative of sine is cosine. The derivative of 1 is 0. So, and then the way I do this is I solve it for dx, but some of you do it differently, so I'll go quickly here. So there's when I solve it for dx, and then I rewrite the integral. So I got the integral of, and for now I'm not worried about the limits, just this is like my secret thoughts. So don't worry about these limits of integration until the end. So I got the numerator we had no substitution for, the denominator is just u, and then another name for dx we said was du over cosine x. Boom, boom, those cosine x's go away. So this just becomes the integral of 1 over u du. Make sure you write 1 over u, because this cosine x, this is a 1 here. Because when they cancel out, they become 1s. And what's the integral of 1 over u du? It's the natural log of u. Don't write the plus c, because this is ultimately a definite integral. And then finally, replace the u. Remember, u is 1 plus sine x. So let's write the natural log of 1 plus sine x. Okay, I should probably have bars right there as well. So the integral of 1 over u du is the natural log of u in the bars, which is equal to the natural log of 1 plus sine x. So I replaced the u with x, so that way I don't have to do any, changing these x's into u's. I don't really normally do it that way. So I think this is the best way to do it myself. So now that I have my antiderivative, now we can get out of secret thoughts. So here we go. This is the problem right here. We want to do this definite integral. So the first step for finding a definite integral is to write the antiderivative, which we got in secret thoughts. And then with that antiderivative, we're going to evaluate it from x equals 0 to x equals pi over 2. So that matches this x here. So everything is consistent. Okay, and now what we're going to do is we're going to input the pi over 2 first in this whole expression, and then minus, and then we're going to input the 0 in this whole expression. So that's what I did here. I've got the natural log of 1 plus the sine of pi over 2, because we input the top number first, and then minus, and don't forget you got to write ln again, minus the ln of 1 plus the sine of 0. So here's where you want to use your unit circle sheet. The sine of pi over 2 from that unit circle trig sheet, you'll see, is equal to 1. So the sine of pi over 2 is just going to be 1, which we have right over there. So sine of pi over 2 evaluates to be 1. This one I rewrote. Minus the natural log of 1 plus 0. The sine of 0, as you'll see from that trig sheet, unit circle, is 0. The sine of 0 is 0. Simplifying, the absolute value of 1 plus 1 is the absolute value of 2. The absolute value of 2 is just 2. So just write ln of 2. ln of 2 minus 1 plus 0 is 1. The absolute value of 1 is 1. So minus the natural log of 1. But the natural log of 1 is 0. The log of 1 to any base is always 0. So ln of 2 minus 0 is ln of 2, which is a real number. This is an irrational number. And that's my final answer. So we are done. And it's 11 minutes long. All right, so long, everyone.